Okay, so we're going to do some graphing quadratics. This is the first part of the quadratic test coming up on Wednesday, May 11th. So the graph quadratics, there's a standardized sort of formula for the whole thing. It starts out by determining whether the graph is going to open upward or downward. So the first thing you look at is to say, all right, this one is going to open downward because the A term right here, which is -1, A is negative. That means down. All right, the second thing to do is called the axis of symmetry, which is off of this formula, -b over 2a. So for this problem, it's going to mean a -3, if b is 3, and a is -1, so we've got 2 times -1. So basically what we have is -3 over -2, and that's a grand total of +3 over 2, or you can just use 1.5 decimal equivalent. All right, so that means that on our graph, then, we need to put an axis of symmetry, which is a vertical dashed line, at x is positive 1.5. So that's right here. Like that. And the second step then after that one, or I guess the third maybe, is to find the vertex point. This is the point that's going to be on that dashed line. And you know that one of the coordinates, the x-coordinate, is 1.5. What you don't know yet is the y-coordinate. But you can find it really easily by taking that 1.5 and putting it back in this original equation. So we have negative and then 1.5 squared plus 3 times 1.5 plus 1. So you could do this in your head if you'd like, but I think it's probably just as easy in this case to put it in a calculator. Notice that I put parentheses around the things I substituted. You should enter it exactly how it's written right here, and you will get your solution. So I'm going to take a minute and do that. So I'm literally typing negative, and then parentheses, 1.5, close parentheses, squared, plus 3, parentheses, 1.5, close parentheses, plus 1. And I get 3.25. That 3.25 is the y-coordinate here. So I'm going to plot this point on our graph. Over 1.25, over 1.5 and up 3, and 3.5 is here, so a little more than that, a little less than that, right in here, 3.25. The second step of this is a y-intercept. Y-intercept is a simple one. It's equal to the c value. So for this problem, our y-intercept is equal to +1. So we go to the graph and we put a point at +1 on the y-axis for our y-intercept. The reason that you use this vertical symmetry line anyway is so that you can determine the point on the other side, which it looks like it's going to be right here. Exactly opposite of where the other one was. Now that we have those, we can go ahead and draw our graph. Okay, so let's just go right on to the next one then. And we'll follow the same exact pattern. Hopefully this time you can tell this graph is going to be upward because A is positive this time. All right, let's do axis of symmetry. This time B is 4, so we're going to have -4, and A is 2. -4 over 4, that's -1. Now we're going to put that into the problem for our vertex, where we know the x-coordinate is -1, and the y-coordinate we will get from doing 2 with -1 in parentheses, plus 4 times -1, minus 2. If you work this out, it's going to give you -4. goes 2. And finally, we have our y-intercept equal to c. The y-intercept of this one is negative 2. So it's time to graph this. Now it's going to be an upward graph. You know we have a vertical axis of symmetry at x is negative 1, so that's right here. We got to plot the vertex point, which is at negative 1 and negative 4. So over to the left 1 and down 4. We plot the y-intercept on the y-axis at negative 2. And then we have an alternate point on the other side of that one here. And we're ready to graph it. That one's done.